Okay, today's lesson goal is to help you learn and understand how to write electron configurations. Basically, with an electron configuration, what are we doing? We're describing where the electrons are located within the atom. And that's very important to understand where the electrons are because that will give us an insight onto bonding and valence electrons. Recall that when you drew a Bohr atom, you put the electrons around the nucleus in fixed energy level rings. The first energy level ring could only hold 2 electrons. The second fixed energy level ring, which was further away from the nucleus, could hold up to 8 electrons. The third fixed energy level ring could hold up to 18 electrons. And the fourth energy level, or the fourth principal energy level, could hold up to 32 electrons. Now, that's a good approximation, but in reality what's happening is each one of these principal energy levels here is actually then further subdivided into sublevels. The only one that isn't is the first energy level. Because it only has 2 electrons, there is no sublevel. But every other energy level is subdivided into smaller sublevels. So, and it's basically very simple to remember. Whatever level you're in, for the principal energy level, that's how many sublevels you have. So my first energy level only has 1 sublevel. My second energy level has 2 sublevels. And we're going to call that the S sublevel and the P sublevel. My third energy level has 3 sublevels, the S, the P, and the D. And my fourth energy level has the S, the P, the D, and the F. Now, as you can see here in this diagram, there is some overlap of some of the sublevels in different energy levels. So here's my principal energy level again. But when we split them into sublevels, some of the sublevels are higher in energy than the other sublevel. So here, this 2s sublevel is slightly lower in energy than the 2p sublevel. The 3s is slightly lower than the 3p, which again is lower than the 3d. Now, and the same thing accrues up here. Now, what's happening here? This says to me that even though these electrons here are all in the fourth principal energy level, some of those electrons that reside in the 4s sublevel are actually come in the 3d sublevel. And this is where your transition elements start to come into play. Okay? The first transition elements are putting electrons in the 3d after the electrons are put into the 4s. So when we fill electrons up, we always go from the lowest energy to the highest electrons. So we put electrons here first. Once that's filled up, we go to the next level up. Once that's filled up, we go to the next level up. Once that's filled up, we go to the next level, and so on and so forth. So when we write an electron configuration, we are now going to be able to accurately describe where all the electrons are in these particular sublevels. Okay, so I've taken that energy level diagram here and further broken it down again, and this time I've helped you out by putting some details here that would be useful when we go to write our electron configuration. Now, the maximum allowed electrons per energy level, whatever energy level we're in, is defined by this. 2 for the first energy level, 8 for the second, third has 18, and fourth is 32. Now, the general formula for this is 2n squared, where n is your principal energy level. So if I'm in the first principal energy level, n squared is 1, and then 2 times 1 is 2, and that's what I got. If I'm in the second principal energy level, n equals 2, and 2 squared is 4, 2 times 4 is 8. Third principal energy later, n is 3, 3 squared is 9, 2 times 9 is 18, etc., etc. Okay, so once we do that, now we can get a better understanding of where the electrons are. So the next thing we want to understand is that every sublevel is based on where it's located on per energy level. So my first sublevel, my first energy level, only has one sublevel, and that's the S sublevel. The second energy level has two sublevels, the S and the P. Now we call them 2S and 2P, but you will see that that's just because they're in the second energy level. My third energy level has all three, S, P, and D. So there's my S, there's my P, and there's my D. And we label them 3S, 3P, 3D to signify that they are in the third energy level. And the last one is the fourth energy level. 4 has the 4S, 4P, 4D, and 4F. Okay? Now, one more thing before we move on is that the maximum allowable electrons per sublevel are the following. We can only put 2 in any S sublevel. Doesn't matter if it's this sublevel S, or this sublevel S, or this sublevel S. The S sublevel, no matter where it is in the energy level here, can only have 2 electrons. The P only can have 6 electrons. The D, 10 electrons. So if we have 3D and 4D, either one of those is only going to have a maximum of 10 electrons. And then the F can only have up to 14. Once you exceed that value here, or here, or here, whatever, you have to move up to the next energy level if you still have electrons that you have to account for. Okay, so what I've done here is I've rewritten that little chart to help you out a little bit easier here, and I've included these boxes. Now, anytime you see a color, the color here represents one energy level. So here we have one energy level. We have a new color that's yellow, that's the second energy level. And notice my third energy level is broken up into the green here and the green here. They're still part of the same energy level, the third energy level, but remember I said that the fourth energy level, S, is lower than the 3D. Now, each one of these boxes can hold up to 2 electrons, right? And then we can show you how that works in a minute. But if you count the number of electron boxes in each energy level, you will see that the boxes are going to yield the correct number of electrons per that energy level. So my first energy level, I can only hold 2 electrons. So 2 electrons per box, I have 1 box. So there's my 2 electrons can be held in here. My second energy level can hold up to 8. So 2, 4, 6, 8. My third energy level can hold up to 18. 2, 4, 6, 8. Don't forget these. 10, 12, 14, 16, 18. Now I haven't shown all the numbers for the 4, but you can see here if you did the same thing, we have 4P, 4D, and 4F. That would be 32. Okay, so now when we put in electrons into an atom, they go into the lowest energy first. And once we fill up a particular sublevel or level, we then get to move up to the next level, not until then. So let's pick a simple atom here to start with. Let's pick nitrogen. So we have nitrogen here. And we know if you look on our periodic table that nitrogen has 7 electrons. And we've got to put in 7 electrons in here to help us understand where they go. So again, electrons are going to go into the slowest unoccupied orbital first, or sublevel first, and so we're going to put them here. Now the convention is you put an arrow up, and then you put an arrow down. Okay, so they're paired. Each electron is paired with another electron. So the first arrow goes up, the second arrow goes down. They're just opposite spins. That's what it means. So I've put in 2 of my 7 electrons, and I've run out of room in my first S level. So I need to move up. So again, we put the first electron in here, and I still have more electrons, but before I can move up to the P, I have to fill this box. So now I've used 1, 2, 3, 4 electrons out of my 7. Now when we go up to the 2P, the rule of thumb is that electrons don't like each other. So they're going to try to maximize the number of boxes to fill, or the number of orbitals they can fill, before they get paired up. So here we could only we only could pair up. We had to pair up right away because there's only one box. But here we have 3 other boxes, so we can choose. So I call this the creepy bus rule or the empty hotel rule. So people are going to want to sit as far as apart from they can from another person on the bus if they don't know them. So if there's an empty chair, they're going to go sit there first before sitting next to somebody else. So that's why we put 1 arrow here, 1 arrow here, and 1 arrow here. Okay, so have we used up all 7? We have. And you will see there that now we have an electron configuration, and this would be the electron configuration for nitrogen. Okay, so now let's move on and try a new one to the next page. Okay, so let's try writing one for lithium, aluminum, phosphorus. Now we're going to do 3 different ones here. So let's do the first one as lithium. So lithium here we're going to use, lithium has 3 electrons because its atomic number is 3. So we're going to put 3. So let's put them in. So the first thing we have to do is put the first electron here, right? And then we can't move out of this, we can't move up a level here until we fill this first box. So once we fill this first box, then we can move up to the next level and put our last arrow there. So that would be lithium. Okay, so let's try aluminum now. So aluminum, that has 13 electrons. All right, so let's see how we do with aluminum. So we need 13 electrons. So the first thing we're going to do is I need to put my first electron here. And before I can move up again, I need to put my second one here. So I've done that. And now I have 11 more to go. So the next one I'm going to put one here. Before I can move up to the next level of 2p, I have to fill this box with my down arrow. Now again, we're going to fill up the 2p box, but we're going to do it sequentially. So the first electron goes here, first electron second electron goes here, third electron. Now I can get total of 6 electrons in my p sub level, but I've only got 3, so now is when I go back and double them up. Okay, so how many have I used so far? Let's count them. We have 2, 4, 6, 8, 10. So I need 3 more. So I put my first one here, and I can't move up into the p until I do that. So I put my second one here, and then my last one goes here. So how many electrons have I used up? I've used up 13. 1, 2, 4, 6, 8, 10, 12, 13. So that would be my electron configuration for aluminum. Okay, so the last one we have to do is phosphorus. So let's do phosphorus real quick. And phosphorus has 15 electrons. Now you might be starting to see a little pattern here. If I have more than 10 electrons, I'm going to fill up these first 2 layers, right? Because 2, I can put a maximum of 2 here and a total of 8 here. So I'm just going to fill them up already. So I might as well just do that now. I don't have to have any reason to not to do that, because eventually they're going to get filled up. So why not just fill it up now? Because I need to put in 15. These are my first 10 right here. These electrons in these 2 levels are my first 10, so might as well just fill them up. Now I can go back and put in my last 5. 1, 2 down, and then 1, 2, 3. Remember, you don't double them up until we go back. So that would be, now I have 5 electrons here, and if you add them up, that's 15. Okay, so those are the electron configurations for the 3 elements. Now this is a pretty tedious way to do this. There's got to be a better way. So let's look at a new way to do this that we can. It's going to give us the same information as this, but in a shortcut, and our periodic table will help us. So chemists and scientists have come up with a shorthand way to write an electron configuration using a convention that looks like this. Right? Now here's how it works out. The first number here is the energy level of those specific electrons. So if the electrons are part of an atom in the second row or a second period of the periodic table, then you're going to have a 2 here. If they're in the third period, they're going to have some type of 3 here. The S represents one of the specific sublevels that the electrons could be in. So it could be S, P, D, or F. And this superscript number here represents the number of electrons in that energy sublevel. Those specific electrons in that sublevel. It's the total amount in that sublevel. Okay? Now recall, the sublevels S, P, D, and F are the maximum electrons in each, can only be 2, 6 for P, D for 10, or F for 14. Once you exceed those numbers, you have to move up to a different sublevel and a different energy level. So let's see how we use this symbol and write this symbol out for some of the things we've just done. Okay, so here are some examples of what the configuration would look like, what the symbol would look like, and how you would interpret it. So my 1s2 means that there are 2 electrons in the S sublevel of the first energy level. 4p2 means 2 electrons in the P sublevel of the 4th energy level. 1s2, 2s2, 2p4, there are 2 electrons in the sublevel of the first energy level, 2 electrons in the sublevel of the second energy level, and 4 electrons in the P sublevel of the second energy level. So 1s2, 2s2, 2p4. First energy level, S sublevel, 2 electrons. Second energy level, S sublevel, 2 electrons. Second energy level, P sublevel, 4 electrons. Okay, so now we're going to choose to try to write a true electron configuration. Now we're first going to model again with the box this way, and then we're going to translate it into a electron configuration. And then eventually we're going to just use our periodic table. We're not going to need any of this stuff. So let's do this again. Remember, let's do for lithium real quick. So here's my lithium. We have 3 electrons we have to do. And if you remember correctly, there is 1 up, 1 down, and then 1 up. Now how do we write this down in a format that we can actually use now instead of these box things? Well, my first energy level is filled. That's this energy level right here. I can't put any more stuff in there. So when I said here, remember the first one was first energy level, sublevel, and then how many electrons. So all we're going to do is just translate that into a number now, a symbol, 1s, and we have 2 electrons in here. Let's count them, 1, 2. So we're going to put the number 2. And that's read 1s2. Now we have to move up to the next energy level, and that's a 2. And it's still in this S sublevel. And then how many electrons do I have? 1. So there would be my electron configuration for lithium. Okay? Let's try it for the next one. Let's try it for aluminum. Okay, so now we're going to do aluminum. So I'll put aluminum here. And we have 3 electrons. 13 electrons. So let's count them again. If you remember correctly, let's put these with the red. So there's 1 up, 1 down, 2 up, 3 down. I'm just doing this really quickly. Remember, the first 10 electrons are already filled, right? Because we need 13. These are my first 10 electrons, and they're going to be filled already. So we're just going to fill them right up. And then we have 1, 2, and then 1 here. So do I have 13? Let's count them. 2, 4, 6, 8, 10, 12, 13. So I got 13. Now all we're going to do is rewrite all these boxes and stuff here into a chemical electron configuration. So let's do that now. So my 1s level is all filled up. My 2s level is all filled up, and my 2p level is all filled up. So we're going to quickly do that. So 1s, The maximum I can get is 2, so I'm going to put that there. My 2s is all filled up, so I put 2s2. And my 2p has a maximum of 6, so that's all filled up. So I put 2p6. Okay. Now I have my 3s, that's filled up, 3s2. And I'm running out of room, so I'm going to go down one below. And what I may have left, I have 3p, and how many do I have? 1. So that would be my electron configuration all in one row. Everything's there. I have electrons in my first energy level. I have electrons in my second energy level, both in the S and P sublevels. Maxed them out. I have electrons in my third energy level, in the S sublevel and the P sublevel. And it matches here exactly. All right, so let's do a lithium phosphorus real quick and try that one. Okay, phosphorus is P, and we have 15 electrons. Now, as you can see the trend here, we know already that all of these electrons right here are going to be filled up. They have to be, because there's 2, 4, 6, 8, 10. So we just might as well fill all the boxes in right now with the electrons. We don't have to waste time counting them. We already know all 10 of those electrons are filled because we have 15. So the lower 10 are already done with. So these are 8, and these are 2. Now I have 5 more to go. So I'm going to put the first one here. And I can't move up to the 3p. I can't move up here until I fill in my 3s. So I have to fill that one down here. Now I can move up to the 3p. 1, 2. Remember the empty bus rule, or creepy bus rule. Or the Hans rule it's actually called, but we'll call it the creepy bus rule. 3p, 3. So let's count and make sure we have all our electrons accounted for. There's 2 here, there's 8 here, that's 10, 12, 13, 14, 15. So I'm all done. Now, we're going to write the electron configuration now, just based on what we have here, right? So I'm going to start right here just to make sure we got enough room here. So we have 1s2. Those are filled. My 2s1s are filled, so that's 2s2. My 2p's are filled. My 3s2s are filled. And my last one is my 3p's. I have 3 of those. Okay, there's my electron configuration for phosphorus. Now, how do I know I did it right? Well, you can just add up all the superscripts. 2, 4, 10, 12, 15. Okay, so let's see how we can actually use this with a periodic table now instead of this chart right here. Okay, remember your periodic table that we gave you actually has all the information you need. Remember, these elements here are our S subblock elements. These are our D, these are our P, and these are our F. So every time you go through here, it's like going through Monopoly. You land, you keep going, until you finally land on it. So if I'm landing on oxygen here, then I know that all of my 1s sublevel is filled up, my 2s sublevel is filled up, and I'm partially filled on my 2p sublevel. If I had silicon, I know that my 1s sublevel is all filled up, my 2s sublevel is all filled up, my 2p sublevel is filled up, my 3s sublevel is all filled up, and I'm partially filled on my 3p. So the electron configuration just writes itself as long as you keep following the little map. 1s2, 2s2, 2p6, because that's all filled up, 3s2, that's all filled up, 3p1, 2. So 1s2, 2s2, 2p6, 3s2, 3p2. And if you could continue it up, right? Now, the only tricky part is once you get past calcium, it's 4s2, then you have to go back to 3d, eventually 10. So if you add up all the 3's, there's 3s2, so that's 2 there, 6 here, and 10 here. That's the 18. All right? It's no harder than that. Try not to overthink it. Is my first energy level filled with electrons? Yes, because I'm much further down on the periodic table. So this has to be filled, this has to be filled, this has to be filled, etc., etc. The further down you are, the levels are more filled up. And here's a quickly a schematic of how they fill, just so you know. Here's the electron order that they fill. 1s2 fills 1s first, 2s, then the 2p, then the 3s, 3p, 4s, 3d, 4p, 5s, 4d, etc., etc. And the periodic table tells you that. 1s first, 2s next, 2p next, 3s next, 3p next, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, etc., etc. So if you just follow the periodic table, there's a little bit of hiccup here with the 3d and 4s. Remember the lower, higher energy level. You'll be fine. So try your homework tonight and see if you can get that. If you can't, come in tomorrow and we'll figure it out together.